Welcome to the walkthrough for Assignment 1B. The objective of the second part of this two-part assignment is to deepen your experience using Android Studio to develop and test an implementation of an array interface written using a combination of Java's object-oriented and functional programming features. It's important that your array implementation work properly, since variants of it are required by all subsequent assignments in this course. The code you write for this assignment has a GUI and runs as an Android app. Please use this GUI to help debug your solution. The following resources may be helpful in completing this assignment: the Java Utils Arrays documentation and the Oracle Java tutorial. Before you get started with Assignment 1B, you'll need to complete your implementation of Assignment 1A and incorporate any necessary changes into your Assignment 1B solution based on my review of your Assignment 1B submission. The Image Crawler app is packaged as a project using the latest version of Android Studio. The app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 1B, however, you only need to be aware of the following three directories: Image Crawler Utils, which contains the skeletons you need to fill in, as described below; Image Crawler Source Test, which is a set of unit tests that exercise the features you're implementing, and we use them to evaluate whether you've correctly satisfied this assignment requirements; and Android Test in the App Source Android Test folder, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you need to select an emulator that uses an API greater than or equal to 29, though I recommend you use API 30. If you don't already have one created, you can create it by clicking on the AVD Manager button in the Android Studio IDE. An array is an abstract data type, or ADT, implemented as a single contiguous buffer that provides operations like get, set, add, remove, and size. Your task is to implement a generic array class in Java. This class is different from Java's built-in arrays in various ways. For example, it can be resized and used in conjunction with other Java collection framework classes. Your task in Assignment 1B is to implement a generic array class in Java that includes methods such as replace all and for each, using modern Java features, such as functional interfaces. You'll need to modify several files containing the skeletal Java code by completing the to-do uFillInHere task to provide a working solution. Do not change the overall structure of the skeleton, just fill in the to-do tasks, and do not remove the to-do tasks. In particular, you'll need to finish implementing the following to-do tasks for this assignment in the utils folder, starting with UnsynchronizedArray.java, where you'll need to complete the to-do tasks and various methods to implement an array interface above and beyond what you did for Assignment 1A. Graduates should now implement code with the tag to-do, graduates 1B, undergraduates 2A, and undergraduates should ignore these to-do statements for now. You'll also have to modify the to-do part of student.kt to set the type field to include just graduate or undergraduate, depending on which version of the assignment that you're implementing. Graduate students, or students who are taking the course for graduate credit, must do the following additional work: implement the requirements of the Splitterator interface. Please see the videos here and here for more information on Java Splitterators. It's important that you avoid using loops in this assignment as much as possible, and instead use arrays.copyof and/or system.arrayCopy. This isn't possible for all parts of the code, of course, but please try to minimize the use of loops as much as you can. Skeleton code for this assignment is available here in my GitHub repository. Now that you've set up your GitLab account, you can pull this skeleton code into your repository, read it carefully, and complete the to-do markers. The additional work required by graduate students is clearly indicated. There are unit tests in the Image Crawler Source Test folder that are provided to increase your and our confidence that your implementation is working as expected. You'll need to use the Android Studio GUI to run these unit tests locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit test to detect problems in your code. This assignment is intentionally designed to be easy to help you get familiar with installing and using Java, Android Studio, and GitLab, Git, and GitHub, as well as some core modern Java object-oriented and functional programming features. If you find it hard to implement or hard to complete this assignment, you may not be ready to take this class. If this is the case, please see me as soon as possible to discuss your options. So now that we've given an overview of the specification, let's talk about the skeletons that you'll have to implement in order to provide your version of Assignment 1B. There are three files that you'll need to modify, and these are in the utils directory. First is the student.kt file. This may be your first foray into Kotlin. If so, don't worry about it. It's pretty simple. Just get rid of undergraduate and say graduate. So that's just there so that it knows that you're a graduate student and will run the test accordingly. The next file that you'll want to modify is UnsynchronizedArray.java, which looks a bit like what we had in assignment number 1A, but there's some new things to fill in this time. And so that's what we're going to talk about today, and then we'll talk about another file as well. So a lot of this stuff is kind of cutting and pasting from what you did from assignment 1A. Please make sure you go back first and address my comments from assignment 1A. So don't be, make sure you get assignment 1A working and passing the unit tests before you cut and paste it and put the implementations into assignment 1B. No sense in bringing over code that you know is flawed. So you'll fill in all the stuff here. A lot of this stuff is the same. I mean, it's pretty much identical. And then we'll get down a little bit later in the file and we'll see the stuff that comes as part of assignment 1B. So you can see here that you'll have the iterator. That's the same as before. And here's the replace all operator. So this gets you a chance to actually do some sort of functional programming. And what you'll do here is you'll use a loop. And this is actually, again, one of the few circumstances where a for loop is probably the best way to go. In fact, it's probably the best way to do it is with an index-based for loop, which I generally don't like, but it turns out that in this case, you want to kind of go through all the elements in the M element data array up to M size, not including M size, but up to and not including M size. And you want to basically go ahead and call the unary operator on each element and then update the value that's at that location in M element data. So that's what replace all does. Then down here, we have the for each, the for each method. You can use your implementation of the for each loop from assignment 1A. And there were a lot of people who didn't quite get that right. So make sure you get that right. And then down here for assignment 1B, because now we're kind of getting a little further along, you'll use the Java stream for each method. So you'll have to figure out how to do that. Again, it's not very hard, but that's what you'll do there. And then the other stuff you'll do that this is really quite different from before, because we didn't do it before, is implement a Splitterator. And so you'll basically implement a Splitterator here, and we'll talk more about what a Splitterator is in just a second. And then, of course, you have to fill in the appropriate implementation for your array iterator. So make sure you address the comments I left for you for assignment 1A for your iterators, or take a look at the frequently made mistakes if I didn't review your code, and make sure you have your iterator next, has next, and remove methods all working properly. Okay, the third file that you'll need to modify is the one that's called ArraySpliterator. And a Splitterator is a really cool feature that was added in Java 8 and of course has perpetuated since then. And it's basically kind of an iterator on steroids, if you will. And in particular, it's used in the Java Streams framework very heavily. And that's why we're implementing it, because we're going to need it later for other assignments. So a Splitterator basically makes it possible to traverse every element in a data structure, in this case in our array, as well as partition the elements. So you'll have to add a bunch of fields. You'll have to add the array to traverse and or partition. You'll have to keep track of the current index, which will be modified in the methods called advance or try advance and split. And then there's also another thing here, which keeps track of one past the end of the Splitterator range. And you can kind of see that as a way to keep track of when you've reached the end. The constructor for ArraySpliterator will take the array, the origin, and one past the end and update those fields. So that's pretty simple. And then there's two methods that you have to implement here. The first method is called try advance. And try advance is what's used to advance by one. You can think of try advance as basically a combination of has next and next in an iterator. So as you recall, has next returns true if there's something that could be iterated over by calling next, and next returns that element. Try advance returns true if you should continue, or the streams framework should continue to try to advance, and it returns false if you've reached the end. And if you reach the end, you return false, and you know that you've reached the end because you keep track of the index and you see when it equals the end. And likewise, when it hasn't reached the end, then you're going to go ahead and essentially accept the element at that location in the array into the consumer action. So this will give you a chance to play around with consumers. And it's just kind of a nifty way of being able to pass results back to the caller, essentially by reference. So if you go back and watch the consumer video that I put out, you can see how to do that. Try split is more interesting. The specification of it's a little bit cryptic, but it actually means what it says. It says, returns the splitterator covering the elements that will, upon return from this method, not be covered by this splitterator, which is a great example of an absolutely true specification, but it doesn't really tell you what to do. So what you're going to do here is you're going to essentially see whether or not there's more than one element left in the array at this point, in the splitterator at this point. And if there is, if the size of the splitterator that you're splitting is greater than one, then you're going to do something. And if it's equal to one, or it's less than one, but it should be equal to one. If it's equal to one, then you're just going to go ahead and return null, says I'm done. If it's greater than one, you're going to figure out the midpoint, and you're going to go ahead and update this splitterator to include this splitterator being the method, the object on which try split is called. You're going to update this splitterator so it's now going to be the latter half or the second half of the splitterator. And then you're going to make a new splitterator, a new array splitterator that will cover from the beginning to right before the middle that you just used to break it in two. So that's why it's called try split. You basically divide and conquer by splitting the splitterator if it's greater than one, if it has more than one element in it. And this splitterator will then have the latter half, and then we'll make a new splitterator that gets returned as the result of try split, which will cover the first half. So every time try split gets called, it's very trivial to divide the array splitterator or the array to be covered in half, because we could do that by taking the beginning and the end and dividing by 2. And that'll tell us the midpoint. And that's what we use to split into 2 splitterators. And this particular capability won't be used for the sequential streams program, which is the first one we're going to do, but it will get used later when we start talking about parallel streams, because the splitterator is what's used to chop up the input of the array into chunks and then process them in parallel using the common fork join pool. So super cool capability, and you'll get a chance to play around with splitterators. And we'll work with other stuff later as well, like collectors and so on, when we get to later parts of the course. So that's basically an overview of the skeletons that you'll have to implement. So now that we've shown the implementation steps that you need to do in order to implement the skeletons, let me just show you how to run the unit tests. It's very simple. You just come down here and you click Run Tests in the crawler, and that should go ahead and start compiling everything. And I think if you come over here to, let's see, well, it's basically compiling at this point, and it'll take a little while to compile. But as it compiles, and once it's done compiling, it'll then go ahead and start running all the various unit tests. And as you'll see, when you watch it, there's a lot of unit tests that get run. And so we have unit tests that test sort of the object-oriented parts of things. We have unit tests that test the other parts. And if all goes well, you should end up basically saying everything passes. There will be some tests that will be ignored. You can ignore the ignored tests, but there's a bunch of tests that are going to be run, and you should come back with all the tests passing. And this is a good way to figure out whether you've got your implementation working or not. And all you have to do is just run this stuff like I showed you there. There's other ways to run it too from the Gradle tab, but this is probably the most straightforward way to do it. So if everything goes well, then you'll end up with all your tests passing. And it may not pass at first, but that will give you a sense of what to look for in order to track down the problems that may be occurring.